Hello everyone, welcome back to the channel. In today's lecture, we are going to discuss an important device in power electronics, the power diode. We'll cover what is a power diode, its VI characteristics, reverse recovery characteristics, types of power diodes, and finally, their practical applications. So, let's get started. What is a power diode? A power diode is a special type of diode used in power electronic circuits, designed to handle higher currents and voltages compared to regular signal diodes. Like any diode, it has two terminals, the anode and the cathode, and it allows current to flow only in one direction. When a p-type semiconductor with positive charge is joined with an n-type semiconductor with negative charge, a p-n junction diode is formed. When p-type and n-type materials are joined, electrons from the n side diffuse into the p side and recombine with holes. Holes from the p side diffuse into the n side. This movement creates a depletion region, no free charge carriers. An electric field is established at the junction, opposing further movement of charges. This built-in electric field creates a potential barrier, 0.3 volt for germanium, 0.7 volt for silicon. Let's see the construction of power diode. A power diode has PIN structure, P plus region. A heavily doped p-type region formed on the N- drift layer serves as anode. N drift region. A lightly doped or nearly intrinsic N-type semiconductor layer is epitaxially grown on N plus substrate. A depletion layer forms at the junction of the P plus and N- regions. N plus substrate. This is heavily doped bottom layer, acting as cathode. Power diode has vertical configuration. Vertical configuration increases the cross-sectional area of the device, so current rating has increased. Drift layer or lightly doped region inserted between the P plus and N plus layer to increase the voltage rating. VI characteristics of power diode. The y-axis upward represents forward current. Downward shows reverse current or leakage current. The x-axis right side, we have forward voltage. Left side, we have reverse voltage. At first, no current flows until we reach a small cut-in voltage. This is about 0.7 volts for signal diode and 1 volt for power diode. After this point, the diode starts conducting. In drift layer doping and charge concentration is low, so conductivity is low and resistance is high. So IR drop dominates exponential characteristics. In reverse bias, the maximum reverse voltage that a diode can withstand is known as the peak inverse voltage PIV. A tiny leakage current flows, but if the reverse voltage exceeds PIV, breakdown occur, and reverse current rises abruptly. Let's see the comparison between power diode and signal diode. Comparison of power diode with signal diode. Power diode larger in size to handle high current and voltage. Signal diode is small and compact. Signal diode current rating is low, typically in milliamperes range. Power diode current rating is high from a few amperes to several kiloamperes. Power diode voltage rating is high, tens to thousands of volts. Signal diode voltage rating is low, less than ~100 V. Power diode switching speed is slower due to larger junction area and stored charge. Signal diode has very fast switching. Power diode power dissipation is high, designed to withstand heat and large losses. Signal diode very low power dissipation. Application of power diode in rectification in power supplies. HVDC, motor drives, inverters. Application of signal diode in signal processing. Clipping, switching, small rectifier circuits. Power diode has large junction area to handle more current. Signal diode has small junction area. Reverse recovery time is longer for power diode. Very short reverse recovery time for signal diode. Usually silicon with robust packaging is used for power diode. Silicon or germanium, typically glass or plastic encapsulation, is used for signal diode. Example of power diode is 1N1184 BYT12. Example of signal diode is 1N4148 1N34A. Now let's understand the reverse recovery characteristics of power diode. When a power diode is switched off, the forward current falls to zero, but then briefly continues in the reverse direction because of charges stored in the space charge and semiconductor regions. This reverse current rises to a peak value and then decays back towards zero. The reverse recovery time is the interval between the instant the forward current reaches zero and the instant the reverse current has fallen to 25% off. After the diode regains its reverse blocking capability. From the figure above, we see that TRR is equal to TA plus TB. TA is equal to time when charge from depletion region is removed. TB is equal to time when charge from semiconductor region is removed. Also from the figure, we can say that IRR is equal to TA dIdt equation 1, where dIdt is the rate of change of reverse current. The area enclosed by the triangular region in the above figure represents the total charge stored, also known as the reverse recovery charge, QR. Hence, it can be expressed as QR is equal to area under the reverse recovery current curve, or equivalently, QR is equal to a half IRR TRR equation 2, where IRR is equal to peak reverse recovery current, TRR is equal to reverse recovery time. Now, for TATRR, putting in equation 1 and combining with equation 2, we get TRR is equal to root to QR dIdt equation 3. Putting equation 3 in equation 1 for TATRR, we get IRR is equal to root to QR dIdt. Equation 4. From equation 3 and 4 we can see that TRR and IRR depend on Q, which in turn depends upon the initial forward diode current IF. Another interesting parameter is defined for power diodes from its turn-off characteristics known as softness factor, S factor, defined as the ratio of times TB and TA. Hence, S factor is equal to TBTA equation 5. If a diode has S factor equals to unity, it is known as a soft recovery diode, and for S factor less that unity, it is known as fast or snappy recovery diodes. Types of power diode. Power diodes are semiconductor devices designed to handle high voltage and current in power electronic circuits. They are classified based on their recovery characteristics, construction, and application. 1. General purpose diode. Reverse recovery time T 25 ms. Slow. Material silicon. C. Applications: low frequency rectifiers, 50 Hz, 1 kHz, battery chargers, power supplies. Example: standard PN junction diode. 2. Fast recovery diode. Reverse recovery time T 0.1 ms, 5 ms. Faster switching. Used in high frequency converters, choppers, inverters, SMPS. Construction: gold doped silicon to reduce carrier lifetime. Advantage: reduces switching losses and reverse recovery current. 3. Schottky diode. Construction: metal semiconductor junction instead of PN junction. Forward voltage drop VF 0.2 to 0.45 volt. Low. Reverse recovery time almost zero, very fast. Used in high speed, low voltage applications such as DC-DC converters, RF circuits. Limitation: low reverse voltage rating, usually 200 volt.